Rebuild the accident inside high-fidelity physics software, place every reflector exactly where it stood, and the result is terrifying. One tiny slip transforms a harmless metal sphere into a lethal radiation weapon in less than a millionth of a second. By the end, you'll see exactly how the same plutonium core killed two scientists 9 months apart, why neither accident produced a nuclear explosion, and the horrifying mistake hidden inside both experiments. The object weighed roughly 6.2 kilograms. It was a near-perfect sphere of plutonium-gallium alloy, small enough to hold in 2 hands. But this was not laboratory scrap. It had been manufactured during the Manhattan Project as the core of another implosion bomb. Had Japan not surrendered, material like this might have been used in a third atomic attack. Instead, the war ended, and the sphere remained at Los Alamos. Scientists now wanted to know exactly how close it could come to criticality without crossing the line. That line separated an ordinary radioactive object from a self-sustaining chain reaction. Inside plutonium, stray neutrons occasionally split atoms. Those atoms release more neutrons. Most escape harmlessly. But surround the core with material that reflects those neutrons inward, and the number of reactions begins climbing. Enough reflected neutrons return to the sphere, and the system becomes critical. The core did not need wires, a detonator, or an enemy target. It only needed someone to complete the cage around it. On the night of August 21, 1945, physicist Harry Daghlian worked with the core at a remote laboratory building. He was constructing a neutron reflector from heavy tungsten carbide bricks. One by one, he arranged them around the plutonium while instruments measured the growing reaction. You can reproduce the logic in simulation. Each brick changes the geometry. Escaping neutrons strike the dense reflector and scatter back toward the center. The closer the enclosure comes to completion, the more efficiently the core feeds itself. Daghlian reached for another brick. His counter warned him the addition would push the assembly too far, so he began pulling it away. Then the brick slipped. It fell directly onto the structure. The neutron population surged. Witnesses later described a blue glow. Daghlian immediately knocked the brick away, then dismantled the reflector by hand. The reaction had lasted only a moment. But radiation does not require time to feel long. There was no mushroom cloud. No blast wave. No shattered building. That made the accident more sinister. A criticality excursion is not a miniature atomic bomb. The geometry is crude, the material expands or shifts, and the reaction usually stops before explosive energy can accumulate. But during that brief surge, the assembly releases an intense pulse of neutrons and gamma rays. Your senses cannot reliably warn you. The room can look almost unchanged while energy tears through living tissue at the cellular level. Daghlian received a massive whole-body dose. His burned hand became the visible center of an injury spreading everywhere at once. Doctors tracked the decline: nausea, weakness, tissue damage, organ failure. The young physicist died 28 days after the exposure. Safety changes followed. Experiments were moved. Procedures were reconsidered. Yet the plutonium itself survived. And instead of being destroyed, it returned to the laboratory. 9 months after the first accident, the same sphere sat beneath another scientist's hands. Louis Slotin was experienced, confident, and famous for assembling dangerous components quickly. His experiment used 2 beryllium hemispheres as neutron reflectors. The lower shell cradled the plutonium. Slotin lowered the upper shell over it, bringing the system closer to criticality while keeping a narrow gap open. That gap was everything. Close the shells completely, and reflected neutrons could multiply fast enough to make the core supercritical. The approved precautions included spacers that physically prevented full closure. Slotin did not use them. Instead, he held the upper hemisphere with one hand and controlled the gap with the blade of a flathead screwdriver. It was a technique so dangerous that physicist Enrico Fermi had reportedly warned the experimenters they could be dead within a year. And here is the part almost every retelling misses. Slotin was not alone. 7 other men stood nearby. Their positions would matter because radiation exposure obeys geometry. Distance, shielding, body orientation, each changes the dose. Modern high-fidelity models can reconstruct the room using particle transport calculations. The software follows enormous numbers of simulated neutrons, where they scatter, what they strike, and how much energy reaches each body. But before we get to what that reconstruction exposes, you need to understand something even stranger. The core had already demonstrated exactly how it could kill. The first accident was not an unknowable equipment failure. It was a warning written in burned tissue. Yet the second experiment still depended on a human wrist, a slippery metal shell, and the tip of a screwdriver. On May 21, 1946, Slotin began lowering the reflector. The screwdriver slipped. And the upper hemisphere dropped. The core went prompt critical. For a fraction of a second, each generation of fissions created enough neutrons to drive the next generation almost instantly. A blue flash filled the room. Heat touched Slotin's skin. One observer reported tasting something sour. Slotin reacted immediately, throwing the upper shell away and ending the excursion. Then came an eerie silence. He reportedly told the men to mark where they had been standing. Someone sketched the room. Their bodies had become radiation detectors, and their locations were now evidence. Slotin stood closest. His body also shielded some of the men behind him, absorbing radiation that otherwise might have reached them. But survival was never guaranteed by one heroic movement. The exposure had already happened before anyone could blink. Dosimeters and calculations could only estimate the damage. The biological countdown had started. Now reconstruct the physical conditions. A plutonium sphere sits between beryllium reflectors. Leave a narrow air gap, and enough neutrons escape to keep the system below critical. Reduce that gap by only a tiny distance, and neutron leakage collapses. The reflector sends particles back into the plutonium. Fissions multiply. The neutron population rises exponentially. That is the reveal. The screwdriver was not merely holding 2 pieces of metal apart. It was functioning as the final safety system for a nuclear chain reaction. When it slipped, the shells briefly formed an efficient neutron trap. The core released an estimated burst of roughly 10 quadrillion fissions, immense on a human scale, but far below the sustained reaction required for a nuclear detonation. So the room remained standing. The people inside it did not remain unchanged. The exact simulation makes the true horror visible. There was no safe moment after the shell dropped. Human reflexes operate in tenths of a second. The decisive physics unfolded in microseconds. Before Slotin's brain could register the flash, the lethal dose had already crossed his body. Slotin began vomiting soon after the accident. His hands swelled. His condition briefly appeared to stabilize, the deceptive latent phase of acute radiation syndrome. Then his body began failing. His white blood cell count collapsed. Internal systems deteriorated. Radiation burn spread. 9 days after the flash, Louis Slotin died at 35. The other men received lower doses and survived the immediate aftermath, though questions about long-term effects followed them for decades. Los Alamos finally ended this style of hands-on criticality testing. Future assemblies would use remote controls, greater distance, and physical safeguards that could not be casually removed. The lesson had cost 2 lives. Daghlian's accident came from one falling brick. Slogans came from one slipping screwdriver. Different reflectors, different rooms, same core, and the same fatal belief that skill could substitute for engineered safety. Only afterward did the sphere acquire the name history remembers. The demon core. The name makes the plutonium sound cursed. It was not. The core had no intention. No hunger. No memory of the people it killed. That is what makes the story worse. Its behavior was completely consistent with physics. Place enough reflective material around it, and the neutron chain grows. Remove the reflector, and it stops. The danger was measurable, repeatable, and understood. After the accidents, plans to use the core in a later test were abandoned. It was eventually melted down and recycled into other material. No haunted artifact remained in a vault. Only reports, diagrams, dose estimates, and a principle modern nuclear safety still treats as sacred: never let one person, one movement, or one improvised tool stand between a stable system and catastrophe. The demon was never inside the core. It was inside the procedure. If this broke your brain a little, subscribe. We drop one of these every week. Because the next file is even harder to believe: Operation Northwood's proposed attacks on Americans to justify war. It was not an internet rumor. It was a real Cold War proposal, preserved in government documents, describing staged violence, fabricated evidence, and a plan to blame another country. And someone was expected to approve it.